All right, guys, so we're going over the review sheet today. So the test is going to be two parts. One part solving systems, one part are partial fraction decomposition. And I want to be nice with this here, and I'm just going to say the solving system. It will say on the test, just solve the system. It does not specify method of solving. So I have a feeling most of y'all are going to solve it by matrices. Yes? Yep. Now, one of the big things I will mention with solving it by matrices is the variables do need to be in order. So x, y, or x, y, z, and this here. We need the variables in the same order. So when we look at the first one here, x minus y equals 2, 6x minus 5y equals 16. X is first, y is second, equals number. So that's fine. So we can set it up as its matrix. So the augmented matrix is going to be 1, negative 1, 2, 6, negative 5, 16. Second matrix, over to edit, it is a 2 by 3. We have 1, negative 1, 2.
Good afternoon, Colcord High School. The annual volleyball tournament is May 1st. There's a $2 entry fee and concession.
6, negative 5, 16.
If you want to sign up as a team, it's $5 per person, 6 to a team. You can sign up in Ms. Berkner's office, or Ms. Berkner's room. Thank you. Have a great day.
And once we get it typed in, we can go second quit. Second matrix, over to math, and we want to find RREF. And second matrix A. And we get this here. Now, since we do have a diagonal of 1s, 1, 0, 6, 0, 1, 4, it's telling us that the variable that went first is 6. Second one would be 4. So since x was first, x is 6, y is 4. Questions on number 1? Now, if we were solving this by hand, we would want to simplify those decimals out, make them a little bit easier to work with. But with the calculator, x, y number, x, y number. We're just making sure here x is first, y is second number. So you'd have 0.5 for x, 1 for y, negative 3.5. On bottom, we'd have 1, negative 3.2, 3.4. Then we can type this in. So second matrix, over to edit. It is still a 2 by 3. 0.5, 1, negative 3.5. 1, negative 3.2, 3.4. Second quit. Second matrix, over to math. We want to find RREF. And then we recall the matrix that we put it in, giving us negative 3, negative 2. So the calculator doesn't care what form it's in, decimal, fractional, whatnot. We do get this here. Now, if it does give us decimal numbers, we can go math. The first option is fraction, enter, enter. It'll convert it to fractions if we do get decimal answers. Questions on 1 or 2? Questions on 3 or 4? Questions on the first 4? We good with the first 4 problems? Yeah. Questions on 5 or 6? That should be an X. We good with problems 5 and 6? Yes, no? Yes. So 6, 2x plus 4y equals 5, 16x plus 50y equals 55. Again, with solving these systems, we do need to make sure variables on one side, numbers on the other, and their variables are ordered, x, y. So we have that here. Now our matrix going across the top would be 2, 4, 5. On bottom it's going to be 16, 50, 55.
Oh, that's equal.
No, you're good. Second matrix, over to edit. Now it is a 2 by 3 because we have 2 equations, 3 spots, 2 variables, and a number. Across the top it'd be 2, 4, 5. On bottom it's going to be 16, 50, and then 55. Second quit. Now we can go second math over to second matrix over to math, find RREF, recall it here. Now if you notice, both of our answers are decimals. But if we go math, enter, it tells us both of them are 5/6. 5/6, comma, 5/6. Questions on number 6? Now there's not going to be one exactly like number 7 on the test, but this first equation, if we're going to do this in the calculator or by hand, it'd be nice to get rid of those 2 fractions. So we would look for the least common multiple, or least common denominator between 2 and 3, 6. Because 6 divided by 2 is 3. 6 divided by 3 is 2. And so what that does is we get rid of the denominator here, leaving us with 3 times x minus 1. Our second one is going to be 2 times y plus 2 is equal to, well, 6 times 4 is 24. Distribute the 3, telling us 3x minus 3. And then we have 2y plus 4 is equal to 24. Negative 3 plus 4 is positive 1. Essentially what we needed to do was get the variables on one side, everything else on the other. We had to multiply through by 6 to get rid of those fractions. Once we got rid of the fractions, combine like terms, move the constant terms to the other side, telling us that really this top equation is 3x plus 2y is equal to 23. And then after we type this one into the calculator, we get 7, 1, or x is 7, y is 1. questions on 7. When you look at number 8, luckily, 7x plus 8y equals 6, negative 14x minus 16y equals negative 12. Again, we need x and y, the variables on one side. In order, we need our numbers on the other. Second matrix, over to edit, we have 7, 8, 6. Oh, no. Here I go to. We have a 2 by 3. That'd make a difference. 8, 6, negative 14, negative 16, negative 12. Questions on getting these typed in? We good on getting it in standard form and typing it in the calculator? Yes? Math, enter. So this here, now the bottom row of zeros tells us that we have an infinite number of solutions. 1, 8, 7, 6, 7. So when we took the RREF, we got a bottom row of zeros, 1, 8, 7, 6, 7. Yep. Now, when we set this up as an augmented matrix, the first row is where we put the numbers in front of x, the second was the numbers in front of y, and the third is just what it was equal to. Bottom row tells us that this is infinitely many solutions. Now the top row is telling us that x plus 8/7 y is equal to 6/7. Y can be any number we want. So in the most parts, and on the answer key, I set it as a given value of a. And why we can use this is it also tells us that here at ax plus 8/7 a is equal to 6/7. We solve this back for x, telling us that x is equal to negative 8/7 a plus 6/7. We do have an infinite number of solutions, but that infinite number of solutions is defined by this ordered pair here, where a is any number. Because I will take this here, we could have also said that negative 8/7 y plus 6/7 comma y is also the solution. Because for any given value of y, we can find a point that will work. Because for a 2-variable system, we'll normally put it all in terms of y. 3, we normally put it all in terms of z. Questions on number 8? Questions on number 8 before we look at number 9? 9 or 10? We go with these two here. Okay. All right. Questions on 9 or 10? Either one of those that y'all want to look up. 9. So again, with any of these here, we got to make sure the variables are on one side and are all ordered the same. X, Y, Z is normally how we want to put these. Now, we do have a few where W, we do have a fourth variable. Either put it at the beginning or at the end. Doesn't matter which, I will take either one. But they do all have to be the same. Now, as a matrix, we can write this as 3, 4, -1, 17. 5, -1, 2, -2, 2, -3, 7, -21. Now, when we type this in, second matrix, it's not a 2 by 3 anymore. Now we have a 3 by 4 because we have 3 equations, 3 variables, and a number. And we want to find the REF, reduced row echelon form of it, which tells us that the matrix is 1, 3, -2, X, Y, Z. And that's it. Questions on number 9? Questions on number 10? Questions on 11 or 12? 12. Now, X, Y, Z, we normally, and again, I want it in that form. W, doesn't really, if you want to put it in front of the X, Y, Z or after the X, Y, Z, that's fine. I do have both versions written down. But it's going to be essentially the same, because if we go across the top, 1 for X, 1 for Y, 1 for Z, well, we have 1 W, so it'd be 1 is equal to 6. In the middle, we have 2 for X, 3 for Y. Now, even though it didn't give us a Z, we still have to put it in there as 0. If one of the variables shows up in one equation, we need it in all the others. Net minus W, so -1, equal to 0. Our next one is going to be -3 for X, 4 for Y, 1 for Z, 2 for W is equal to 4. And the last one, 1, 2, -1, 1, 0. So when we have 4 variables, here we have 4 equations with 4 variables. And when we type it into the matrix, it's going to be a 4 by 5. One, 6, 2, 3, 0, -1, 0, -3, 4, 1, 2, 4, 1, 2, -1, 1, 0. 103, 2. And that's it. So it's not any different. We just need to make sure that they are ordered either X, Y, Z, W, or W, X, Y, Z. Now, if you put the W's first, you moved all these to the front spot of the equation. The only thing that would do is tell you that the solution is 2103. Because the value of W is 2, and if I moved it to the front, it would just put that value in front. Does that make sense? Yeah, it just ends up rearranging it. Questions on 11 and 12. 13 or 14? 14. XYZ number. XY, we don't have a Z, so the bottom one would be -4 for X, 9 for Y, 0 for Z is equal to 7. The top is going to be 2, -3, 1, -2. Because we had Z in one of the equations, the other equations will need Z as well. Now this here, if we have 3 variables, really to get a solution, a point, we need 3 equations. So both of these, because we have 2 equations with 3 variables, we're going to have to get this in terms of a or one of the variables. Two by 4. So 2, -3, 1, -2, -4, 9, 0, 7. So we get it typed in. And we get this here. Now, I think it's going to be a little bit easier to work with fractions, especially since one of them is a repeated decimal, or 2/3. 103/2. 103/2, 1/2. Not the one I wanted. 103/2, 1/2. 0, 1, 2/3, 1. 0, 1. So after we used RREF, we put this in reduced row epsilon form, we get this here. So let's see what this says. Now, again, so in both of these here, X went first, Y went second, Z went third, and then our numbers. So for the top one, we say that we have X plus 0Y plus 3/2 Z is equal to 1/2. Or really that we're saying that X plus 3/2 Z is equal to 1/2. That is what the top equation is saying. The bottom set of numbers is that 0x plus 1y plus 2/3 z is equal to 1, or really y plus 2/3 z is equal to 1. Questions on this so far? What variable do both of these two equations have in common? Z. So what we do with this here is the fact that they do share z in common. We can leave z alone, or set in most books, they'll set z equals a. A is a number. Doesn't matter what it is, we can pick whatever number we want because there are an infinite number of solutions that work. And our solution set is going to contain z as a. And what we can do to find the rest is, well, here x plus 3/2 a is equal to 1/2. We're going to solve this for x. These will cancel, giving us x by itself. Well, -3/2 a and 1/2 are not the same. So it's just saying x is equal to -3/2 a plus 1/2. We can do the same thing with y. Y plus 2/3 a is equal to 1. We need to get y by itself, giving us this here. And what that tells us is that x is first. Now, unlike most systems where we have a number, a value, here we have an expression. X is negative 3/2 a plus 1/2. Y is negative 2/3 a plus 1. And z is a. And this is an infinite number of solutions because a can be any value. We can have any value of a. So to find a solution set, we can just start picking values of a, plugging in all three spots, simplify, and that would give us a solution that works. But the infinite solution for this is defined by this here. Questions? Okay. Questions on 13 and 14? Because 13 is going to be similar in nature. They're not always going to have fractions. They can just be nice numbers. Ends up being more of the problem than it is it coming out this way. 15 through 21, the second part of this test is to write the partial fraction decomposition. Now, the first thing we need to do at the partial fraction decomposition is make sure that the denominator is factored as far as possible. And we always look for greatest common factor first. X squared plus x does have a greatest common factor of x. And we factor an x out of x squared plus x, we get 1 over x times x plus 1. That is as factored as it gets, because the degree of the variable outside is 1. Can't do anything with it. Inside, the x plus 1 degree is 1. Factored as far as it possibly goes. Then we list all the factors out in a sum. The factor outside the parentheses x is just to the first, so we would have x. Now, if it had been x cubed, our first denominator would be x. The second one would be x squared. Third one would be x cubed. We keep going up in power. So it's just 1. Then we take our next factor, the x plus 1. Well, since it's also to the first, we just have it once. If it had been squared, we'd have x plus 1 to the first, and then x plus 1 squared. Questions on how we set this up? Now, the degree of the bottom, both of these here, is 1. So we do not have a variable on top. It's just a and b. Now that we have it set up, we're multiplying through by our x and x plus 1. On the far left side, they're going to cancel out completely. Telling us that 1 is equal to, in the middle, the x and x will cancel. Telling us that we have a times x plus 1 plus, in the other fraction, the x plus 1 and x plus 1 cancel, giving us dx. Next thing we need to do is distribute. A times x is ax. A times 1 is a. Don't know why I wrote an equal sign. Plus bx. If it does help, we can reorder our terms. So our terms with x are next to each other. Our terms without a variable next to each other, we just have them grouped. And we can start connecting things together. Now we do have ax plus bx, ax and bx on the right-hand side. Do we have a term with x on the left-hand side? No, so that means that that term is 0. That really 0x is equal to ax plus bx, or 0 is equal to our a plus b. So we'll have to find another equation to help us with this here. Now the other term we had was A, our letters without a variable, and they match up to 1. So that tells us 1 is equal to A, or A is 1. And whenever we get one of these letters by itself is equal to a number, it is not, because it tells us the value of A is 1. And we can use it in the previous one here, because it's really also telling us that 0 is equal to 1 plus B, or the fact that B is -1. And we can use those two facts to come back up and say that this here is equal to, well, 1 over x plus -1 over x plus 1. We go back in and fill in the values of A, B, any of these letters that we had. Questions on 15? Questions on 16? Let me look at 17. Now, a reason I say 16 and 17 are similar is the x squared minus 9. X squared minus 1 is the difference of perfect squares. It would have been x plus 1 and x minus 1. X squared minus 9 is also a difference of perfect squares. X plus 3, x minus 3. So we have 3 factors. We have x, x plus 3, x minus 3. They all show up once, so we only have them once. The degree for each of them is 1. We just have A, B, C on top. And again, just like the last one, we're going to multiply through by the bottom of the fraction on the left. And on the left-hand side, everything's going to cancel, leaving us with x plus 2 is equal to. In our first one, the x and x will cancel, telling us that we have a times x plus 3 times x minus 3. Plus, in the middle, the x plus 3 and x plus 3 will cancel, leaving us with bx times x minus 3. Plus, lastly, the x minus 3 and x minus 3 will cancel, telling us that cx times x plus 3 is all that we have left. Questions on how we got to this point here? Now, me and the book differ a little bit. Here, the book wants us to start just plugging values in for x. That would make any of these sets of parentheses be 0 and work from there. I like simplifying this all the way down and matching up. X plus 3 times x minus 3. Well, where do we get the factors of x plus 3 and x minus 3 from? X squared minus 9. You can multiply it back out. There's nothing wrong with that, because it would give us x squared minus 3x plus 3x minus 9. Our 3x and negative 3x will combine to give us 0, giving us x squared minus 9. The bx, we can distribute it. Bx times x is going to be bx squared. Bx times negative 3 is going to give us negative 3bx. Lastly, with cx, cx times x is going to be cx squared. And cx times 3 is going to be plus 3cx. Now we also need to multiply through by a. Notice that we have ax squared minus 9a plus bx squared minus bx plus cx squared plus 3cx. I just realized that there was supposed to be a 3. I knew I missed a number. 3bx. That's 3bx. Yep. And again, if it does help, reorder them. Ax squared, bx squared, cx squared. Ax squared plus bx squared plus cx squared. Then we have our x terms. Negative 3bx plus 3cx. And lastly, we have our terms without a variable, which is minus 9a. Questions on how we got to this point here? Now we could rewrite this out again as we did before with our, I'd say ax squared plus bx squared plus cx squared. Well, we know that these x squared terms should equal the number with the x squared term on the other side, yes? Well, what's the number in front of the x squared over here? 0. So really, ax squared plus bx squared plus cx squared should equal 0x squared. Or really, 0 is equal to a plus b plus c. Yeah. Because really, all we're doing is just skipping the step going from our equation form to our equations with x squared, then removing the x squared. Our term with x, we do have 1x, or 1 is equal to negative 3b plus 3c. And again, all we're skipping is x is equal to negative 3bx plus 3cx. And the terms without x, negative 9a should match up with our 2. Now the nice thing with a is already by itself. So negative 2/9. The middle equations in terms of b and c. The first equation in terms of a, b, and c. So we can plug a back in. Now we do have b and c. B and c are left in both equations. We're going to have to find b and c using systems of equations. Now I know that b plus c is equal to 2/9. I know that negative 3b plus 3c is equal to 1. Now we can solve this by hand, or, well, I do have a systems of equations, so we can use matrices to solve this. 3, negative 3, 3, 1, 1, 1, 2 ninths. Wrong calculator. Not 23. 2 by 3. Negative 3, 3, 1. 1, 1, 2 ninths. 10 quick. Negative 1/18 and 5/18. B went first, and then C. So negative 1/18, 5/18. Our other two values. And you can put it up there at the top because A, so negative 2 ninths over X, plus negative 1/19 or 1/18 over X plus 3. Plus 5/18 over X minus 3. Really, this we would need to simplify it. I will take that as an answer because you can get at least there. The other option is to simplify the top of that fraction is to factor the 1/18 out, which would give us 1/18 out front. Which for the middle and the third term is just going to be negative 1 and 5, X plus 3, X minus 3. But our first term is going to be negative 4 because factoring 1/18 out of 2 ninths, well, 2 ninths is the same as negative 4/18. So it would simplify to this here. Either one of these would work. Now, all the ones on the test except for the bonus, you're not going to have to worry about these fractions and fractions. The bonus will have it, but the rest won't. Questions on this here? We do have a few more of these here. We're out of time, but do we feel comfortable with these here? Do we need to see more of these partial fraction decompositions? $20 is not going to show up. We're not going to have the numerator with a bigger degree than the denominator. Do we want to look at one or two more of these tomorrow? Okay. We can look at 21 tomorrow.